Hi everyone, so today we're going to continue with tip and tax, and we're going to work through some videos this week that will help you with your Khan Academy. So today is going to be tip and tax equation. We're going to look at the 3 different equations that you can use to calculate tip and tax, and then when you'll use each of them to help you with the examples that I'll work through these next couple days. Okay, so the first equation is when you are given a single step problem. And this is when you're just asked to calculate the tip, tax, discount, any of those. So if they say how much will you save, or what was the tip, or what was the tax, things along those lines. So it's one step. And so your equation would be original total times the percent. And so that will give you your tip or your tax or your discount, whatever you would save. And then this will give you your tip, tax, discount, whatever. So then in a problem, if you're given one of these, you would use this equation to work backwards. They say you left a 20% tip and it was $1.60. What was the original? You would use this equation here because you were given the tip, the tax, or the discount. So this is the single step equation. So an example of this: a store is selling coats for $150. They are on sale for 35% off. How much would you save? So this is a one-step problem. They're just asking what would you save. They're not asking what the new total is. So we're going to use our equation. So we would have 150 times 35% as a decimal is 0.35. And when I multiply those out, I would get $52.50. And then if they gave us here, we could work backwards and solve for either the percent or the original total if they gave us how much we saved. So again, this equation here is when you're given the tip, or you're asked to find the tip, the tax, the discount, or you're given one of these and asked to work backwards to find one of those. So then the other kind of equation is a multi-step equation. And this is for multi-step problems. And so this is going to be for ones where you're asked what's the new total. So after you've calculated tip, tax, discount, what's the new total, or this is the new total, what was the original total? So that's going to be one of these 2 equations. And there's 2 different ones that you can use. So the one that we have been using is original cost plus original cost times the percent, where this section here is the extra that you pay, or what you save. So this part here, as you can see, is exactly the same as our equation up here, and then you're just adding it or subtracting it. This could also be subtract from the original. But the other equation that you can use is original cost times 100% plus or minus the extra percent. So what you would be finding here is the percent that you pay. So if it's 40% off, you pay 60%. If you're giving a 15% tip, you're paying 115% of the original total. So this equation here is super helpful when you're trying to work backwards and they give you the new total. This is the only equation that works in order to find the original cost. This equation you can't use to find the original cost. when given the new total, but this one you can. And so this is going to be your equation for working backwards. Okay, so let's do some examples. And I'm going to use these equations, both of them, to show you how you get the same answer. Yeah, so examples. So a couple goes out to eat. The total is $68. If they left a 20% tip, what is the new total? Okay, so if we were to use either of them, so let's say we use our first one where we do original plus original times percent. So our original 68 plus 68 times 20%. So 68 times 20% is going to be $13.60 plus our $68 at the beginning. And I would get $81.60 as my new answer. For these ones, obviously, I'd already done these, so I knew what the answers were, but you can use a calculator to calculate this. Remember, order of operations in calculators doesn't work. It will add and then multiply, so you're going to want to multiply and then add. And then if I use my other equation, 100% plus 20%, so this here becomes 120%, which is equal to 1.2. So again, if there's no decimal, I start at the end and I move in. So this is our new equation. So this is the percent that I'm paying. I'm paying 120% of the total. And then I can do 68 times 1.20. And if you were to use a calculator to do this, you would get $81.60. So it works. Both of these equations are equivalent. It's just a different way of thinking about it, whether or not you add what you pay or finding the percent that you pay and then multiplying it. And so just then, so you can see the equations written out. So these ones here are the new total, and since we're adding, it's mostly for tip and tax or even markup. But let's look at the equations if we were to do discount markdown, just so you can have those available to you. So the first one is original cost minus original cost times the percent. And this here is the dollar amount that's going to be taken off. And then our other equation is original cost times 100% minus percent off, where this here is going to represent the percent that you pay. So that's why this equation looks this way. So if let's say it was 20% off, you pay 80%. So that's why this equation works. And remember this equation, not this one. This one is going to be the equation that you use for working backwards. Because you can't really, you could distribute and try and work backwards that way, which you would really kind of just end up with this equation here. But because there's two original costs, you can't really work backwards to find the original cost of this equation, where here you can. So an example of this would be a sweater costs $60 if it's 25% off. What's the new total? And we can do it both ways. So First way would be 60 minus 60 times 25%, which would be 0.25. So if I multiply that out, I get 60 minus 25% of 60 is 15, and I get 45. And then over here, if I use my other equation, I get 60 times 100% minus 25%, so that's 75%. So I save, or I only pay 75% of the total because I got 25% off. 60 times 0.75 is $45. So I get the same answer regardless of which equation I use. So when you're going forward, when you're finding the new total, you can use either of these. But if you're working backwards, you were given the new total, you do have to use this one here.